Alright, I'm back from vacation, unfortunately. Really don't want to be back. I wish I was still on vacation, but we're back to our little project here, and now we're going to start working on the knobs. This is the original one that broke. It basically just cracked right down the side there. The way they had it set up is just a little stud that was knurled and just pressed in there. And so I'm going to make this whole piece out of aluminum. And as for the threads, these are metric threads, and they're pretty well screwed. There's a huge ding there. The front here is all munged up here. So we're going to get rid of these, and we're going to go over to a regular imperial screw, regular 7/16. Now, this is pretty close to 3/8. I'm not sure what the metric equivalent is to that, but I went one size bigger. And on the thread size, and I'll show you why in a second. This is the guide bar that those go in, and this here is the tension adjustment screw, and it's starting to crack. Right, it doesn't really show in the camera really well, but there's a hairline crack right there, the tip of my finger. And this is the same thing. You can see a bit of the knurl sticking out there. I'm going to save this, though. These threads are fine, and I don't want to mess with the actual nut that's mounted on the pulley. So I'm going to reuse this, and we'll just have to drill and press fit and Loctite this knurl into our new thing. Actually, I might just put this in the lathe and cut the knurl right off, and see if we can heat it up and maybe press fit it. I'm not quite sure yet. So the plan is to make these out of aluminum. I have 2.5-inch aluminum stock, which is slightly bigger than these, which is perfectly fine, just gives you more leverage. And this is just a stud I made, a 7/16 stud that I'm gonna thread into part of the handle there, and then just have the other side sticking out, and I'll just measure it up to the same amount of exposed threads to this. It's roughly the same size, so that's the plan with that. Now this here, these holes are pretty well on center, but let me show you on the actual saw itself. That's the hole it goes into, right there. The original one, you can see the size difference. You should be able to see the size difference here. See how much of a gap that is? Enough for this to wiggle up and down and lose your alignment every time you go to move this. I wanted to get 1/2 inch in here. 1/2 inch would make this really, really tight. The only problem is there are guide tabs that are cast in the back of this that allow this to slide, and if you notice, it's not on center. In other words, the holes pretty much touch the bottom here. So the largest size I could get in there was the 7/16. It's not much it's a lot less movement than the 3/8, but the 1/2 inch would have been perfect. But I'm not going to mess with trying to recenter those holes that were already drilled and going through that disaster. So we'll work with what we got. So let me just pull over to the lathe here, and I'll show you how we're going to do this. This is going to be our stock that we're using. This is 2.5-inch 6061 T65 aluminum. It's not the hardest aluminum in the world. It machines very, very well, and it's perfectly acceptable for what we're doing. Just making a knurled handle. The actual stress point is going to be the screw itself, which is going to be made out of steel, so we're not going to be tearing threads off of it or anything. Now, as you can tell, obviously this is not going to fit through the headstock here, so we're going to have to use our steady rest here to be able to center drill the side and run it on center, run it with a center if we need to, or we can just use the steady rest and machine the portion that we need, which is probably what I'm going to do. This here, the steady rest I have, which I'll give you a better shot of how to set that up and everything in a second. It will fit in this. The actual hole cutout on these is 3 inches, and depending on how worn your jaws are, they're supposed to come down to a point. These are a little worn. It does fit in there, so we're good to go. It also, I'll just put this out of the way for a second. At least on this chuck, depending on what chuck you have, you may or may not be able to fit it in between the jaws. Actually, never do that. I will be able to fit it in between the outside jaws here. And that's what I'm going to do. I can also turn this around and use the other set of clamping jaws on this, and clamp it on the outside on this. And these are a lot smoother, so if you're worried about surface finish or anything, these have those little serrations. You can use this, and you wouldn't have to put the shims or anything in there to worry about that. But I'm not really worried about making any kind of marks in it, because obviously I'm not going to be using that side. But and it's just a lot easier for me just to throw it in. It gives me a lot more surface area to grab onto. I have about an inch and a quarter here as compared to, just this little portion here that I would be using. So let me get you a better angle on the steady rest and everything else, and we'll go from there. Okay, so here's what we got it set up. I have these jaws. As you can see, I have plenty of engagement of the actual chuck jaw itself in the chuck scroll, so I don't have to flip them around. This is just snug right here. Also, this, because the back of this bar is rough cut, it's not pushed straight against the back plate here. It's off by like a 1/16 of an inch or a 32nd of an inch. These jaws are clamped down just light. I can still wiggle this bar around. Now, depending on the length of your bed and the length of whatever you have on your the length of your bar, you may or may not be able to machine the end in the steady rest. You may have to either part off a piece and then rechuck it, or center drill the end, pull the steady rest out of the way and run it on a live center or a dead center, and then do your machining where you need it. My lathe is long enough that I can machine the end of it. Now, because I'm machining the end in the steady, I have to have my carriage be on my steady rest, obviously. So here's my steady rest. A better light here. Here's the steady. My carriage is on the outside of it. If I was just center drilling it, I don't have to have my carriage here. I can have my carriage on the inside. But I'm going to be machining through the whole thing here. Now, my length of my part is going to be 1.5 inches. So I have this steady rest set from this bolt here 3 inches. So that gives me enough room to play and enough to mount this solid. So I can lock it down there. Just like your tailstock, there's a clamp that clamps between the bedways, but unlike your tailstock, that clamp can go anywhere in the bed. In other words, if you turn it sideways, it'll fit between this gap here on your bedway, so you can lift it straight up, so you don't have to slide it in from the end like you do on your tailstock. Alright, that's all tight. Now, these jaws here are movable. So for right now, at least with just the bottom, I want to come into contact. Let me get my wrench, loosen this one up on the other side. Or if I'm blocking the camera view here. Put them just into contact by hand without tightening these screws down yet. All you want to do is make sure it touches first. There we go. Alright, we're just touching. I'm going to lightly lock those down. Just so they stay in place, and pull these screws in till they just touch. Lock this in, and bring the top jaw down by gravity till it touches. And bring your tension screw in just till it touches. Now I'm going to put an indicator on my tool post here, and we'll be able to indicate this and get this to run true by tightening or loosening each one of these just like you would with a 4-jaw chuck. Now let me get that all set up. I have my indicator all set up there, and we can see how far we're running out. So right now, not very much at all. Maybe 1,000 or so, if that. Is about and plus the surface finish on this is pretty rough, so about 1,000, 1,000 and a half at most, maybe. That's what it looks like to me. So honestly, we can leave that. I'm going to leave that right where it is, because we're going to be taking a skim cut anyway to chew this up, because it does have some surface imperfections. So these, let me get you a good camera view of this, or at least try to. So when I'm going to tighten those down now. Tighten these, set screws down, make sure your clamp is locked down, make sure all these screws are nice and tight. And then on a smaller wrench, just give these locking clamps just a quick little torque, just to make sure that they're putting a little bit of pressure on this, so in case these ever loosen up or anything, they're not going to slide out. Now this has plain jaws. I am on aluminum. These need to be oiled, so I use just the regular whey oil on them. They do make a high pressure grease. They actually make greases for centers too. You can use that. You just have to make sure that they stay well lubricated. Obviously you don't have to worry much about it if you have a steady rest with bearings on it. But so we're lubed up there. Give the chuck a quick little tighten, make sure we're tight on that, and give it a test run. Alrighty, we're slightly tight on that. I can feel it when it starts up, so let me back off my tension. Much better. It's still nice and solid. Got no real wiggle. And we should be all set to machine what we got to machine. Let me get you a better camera angle on that. I got you on the other side of the lathe. This is the best position I could kind of come up with to see what I'm going to do. So I got this all lubed up. I'm going to face off the saw cut and turn a let's see, 5/8 of an inch long. We're going to turn down to 1 inch in diameter. That is going to be this part of the knob here. A little bit of a rough check of saw cut right there. So, by the way, the lubrication I'm using is just WD-40. Works great on aluminum and it's cheap. And we're not really doing any damage to anything there. Put a little bit of oil on there. Perfect. Actually, what I think I'm gonna do is it's not galling or anything, but I'm gonna center drill it and run it on my center for the inch diameter in the knurling and everything else. I'm gonna leave my steady rest right here because I'm gonna need that to be able to drill for the stud, and then also to knurl the end and part off. So I just don't want to listen to that noise for the next 15 minutes. So. Alright, I just got to bring that down to a 1 inch. I'm going to leave the radius in the corner because it doesn't really matter. We're not making anything crazy here. Get this a little more straight on. Zero. Let me grab my pliers. Like these chips, so I'm gonna go grind in a chip breaker on that tool, so that way they come off and break up. I don't want that shooting back at me. Alright, I ground the breaker in the tool, which is basically just a dished groove perpendicular to the work. So when the chip comes off, it'll curl itself through that groove. It's still going to make long, stringy chips. That's just the nature of this material, and that's not a really aggressive chip breaker. But you'll see that it goes off in a different direction, and when I stop the feed, it will immediately cut the piece that is coming off, and it won't spin around like it was before. Yeah, it's coming off opposite direction now. Now if I want to stop it, it'll break right off. Alrighty. Let me switch out. I'm going to face this real quick. And I got a finishing bit. A nice round nose one I'll put. And just give that a finish. And then we'll go on to the next step.